Hello guys, welcome back to my YouTube channel. Today we'll be learning calculation of tension force under equilibrium. Now we'll be taking this first question as case 1. A mass of 2 kg is supported by two cords, which makes angle of 30 degree and 50 degree with the vertical. Calculate the tension in the two cord. Now in this question, we are asked to calculate the tension in the two cord. Now the tension occurs here in P and in Q. How do we go about this? The first step to do to calculate this is to look for the angle of this place. So our first step is to look for this angle and to look for this unknown angle. So what's this angle? Now here is the right angle, which is 90 degree, and this part is what, 30 degree. So to get this part, we just have to take 30 from 90. So this part will be 60 degree. So taking 90 minus 30, we have the angle as 60 degree. So that's what we did. Now how do we get this part, this unknown part? This place is a right angle. So therefore, meaning that from here to this place, the total angle is what? 90 degree. But this place is 50 degrees. So if we cut this place out, we'll have the remaining side here. So 90 minus 50, we'll have the remaining angle here, which is what? 40 degree. Now getting this angle here, 60 degree, getting this 40 degree. So this is the angle, this what? This rope make horizontally with this line. So this is the angle it makes horizontally with this line. It is 60 degree. The angle this rope makes horizontally is what? 40 degree and 60 degree. So what do we do with this? We calculate. But before calculating, we have to know our weight that is acting downward in the system, that is balancing the equilibrium. Now, a mass of 2 kg is supported by two cords. So the mass is 2 kg. So the weight of the mass will be, weight by formula it is mg. So the weight will be, what is the mass? 2 times the gravity is 10. So therefore the weight will be 20 Newton. So therefore the weight here is what? 20 Newton. Now we are set to calculate. Now before we can calculate, we should know that in equilibrium, the sum of force on the horizontal axis is 0. So please take note. Summation of force on the horizontal axis, which is x-axis, is 0. And summation of force on the y-axis is also what? 0. So working with this, we'll get our answer. So please, we move down to the solution carefully. Okay, now, so we have to resolve all these forces into what? Horizontal and then vertical axis, which if we have to resolve it into x and what? Vertical what? Axis, horizontal and vertical axis. Now to do this, it is very easy. So now we ask ourselves, in this diagram, what are the forces that are what? Vertical. So P is the tension, and then 60 degrees is the inclination angle the tension has with the what? Horizontal. So but how do we resolve this 60 degree into vertical and what? Horizontal axis? It is very simple. You should know that your cos represents your horizontal axis, and then your sine represents your what? Vertical axis. So this 60 degree can be resolved into what? Horizontal and vertical axis. So summation of all the forces on the y-axis can now be summation Fy can now be P sine 60 plus Q sine 40 minus 20 Newton. Now recall, the two vertical axis resolution of 60 degree is upward, so therefore it is positive. Therefore the force acting downward is negative because downwardness is negative, upward is positive according to what y-axis. So the upside of y-axis is positive, the downside is negative. So therefore that is why we're having minus 20. Now we know summation of all the net forces under equilibrium is 0. So summation Fy is 0 equals to P sine 60 plus Q sine 40 minus 20 Newton. Now we can collect like term. It becomes 20 Newton equals to P sine 60 plus Q sine 40. We can call this our equation 1. Now, summation of all the x-axis force acting on this equilibrium diagram is what will be taken next. So summation of the fx. Now we have to resolve the angles into what horizontal angles, and I said that horizontal is denoted by cos and then vertical is denoted by what sine. So this is very easy. So resolving it now becomes, instead of p, it becomes minus p cos 60 plus q cos 40. Now this is very easy. 60 is falling on the left hand side of the x-axis, so therefore it will be what negative, and 40 is on the right hand side. Therefore when we resolve it into the horizontal component, it will be what positive. So this is very easy. Now summation of all the force on the what x-axis is what 0, according due to the fact all the system is in equilibrium. So therefore we have minus p cos 60 plus q cos 40. Now we can collect like terms. It becomes p cos 60 equals to q cos 40. Now this is equation 2. So therefore our equation 1 is now 20 equals to, now what's sine 60? Sine 60 is 0.866, so it becomes 0.8660 p plus sine 40 is what 0.6427 q. So this is equation 1, still equation 1. So our equation 2 becomes what's cos 60? This 0.5 p equals to what's cos 40? This 0.7660 q. This is equation 2. Now from equation 2, make p the subject. Now from equation 2 we are making p the subject, so we are dividing both sides by 0.5. So we have 0.5. So my p is now 0.7660 divided by 0.5. So my p is now 1.532 q. Now therefore I will substitute this, I call it equation 3. So I put equation 3 into equation 1. So it becomes 20 equals to 0.8660, and my p is 1.532 Q plus 0.6427 Q. So therefore, my equation becomes 20 equals to, so therefore multiplying 0.8660 times 1.532, I have 1.3267 Q plus 0.6427 Q. Adding the two Q's together becomes plus 0.6427. Then I have 1.9694 Q. Divide both sides by 1.964 Q. 20 over 1.9694 equals to, then I have 10.15 Newton for Q. Now the next thing that is left for me to calculate what? My P. So now my Q equals to 10.15 Newton. Now I'll put Q into equation 3. So I'll get P. So equation 3 is P equals to 1.532 Q. So putting Q, I have 1.532 times 10.15. P equals to 1.532 times 10.15. So my P is now 15.55 Newton. So that's my two tension force. So for Q and P, Q is 10.15 Newton and P is 15.55 Newton. So please, if you kindly enjoyed this video and this video really imparts something in you, please kindly subscribe to my channel. Thank you for watching.